Start number island. Given a 3D, 2D map of one, this is number island. So do you just start at any of these and basically do a traversal, right? So let's say you start at this, you just keep expanding, right? And that's it, right? Guess so. Um, this this is gonna be ON square, right? I don't see any other better solution other than right. Me think you have to loop through all of the point, right? So let's say you start here, you go through these, whatever, right? And then basically it's just expanding, right? right? So you come across one, it's expanding, right? And then when you cannot expand anymore, right? So like a woo, 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 right? Then you return one, right? Uh, Other than that, right? You, I think that's it, right? Um, I'm just gonna go with that. Let's see. Uh, why chat is connected on YouTube? Okay. So the Y bound is length of the grid. The X bound is length of the grid 0. So 4y in range of yb, 4x in range of xb. So if grid yx equal to 1, right? Then we do a DFS, define island. DFS starting at yx and suggest DFS so we have a queue so that we can start it there. Okay. Oh, okay. So we also, because we do this, right, and we pick up again. We don't want to pick up the one we already visited, right? So let's put a visited here. Right. So y, right, okay. So the yx equal q dot pop, right? So after we done with that, we have to add them to, right? Oh, so we gotta count the so from this we can go up, down, left, right, right? Up, down, left, right, right? So we up is up, down, right? So y minus 1 x down is plus 1, left is same y x left 1 right. So q equal to y plus q, right? Okay, we gotta check if inbound yx would be okay. Basically return y greater than 0 and okay, if inbound we always check the up first, right? Okay, so that means let's just all go all up first. So it doesn't matter, I think. Call this traverse. Call it flat fill. Feel like a game stuff. We actually flat fill here. So we gotta say if and yx not in the visitor, right? Then we just visit, right? Oh, so we will have counting. So this will return 1, right? Oh, if inbound and not in, right? And we allow right, maybe Visited. Visited right here. Two is wrong here. Put 1. Wait, what's wrong here? So we go from here to here. We get the island. We visited them, right? Yeah. So let's put a debug here. Path, go. Path plus equal yx, and we have it started at yx, and we give a path we can debug. Oh, we go up, down, left, right, and if we start at 0, we go like this. Why is the path crazy? Oh. And read up gotta be equal to 1, right? There we go. Let's not do this and see if it passed already. Okay, submit. Oh, nothing wrong. Time limit exceeded. Oh. So something we have here doesn't keep going. Hmm. So we have uh, is it possible that this one here got overvalued? Or does this not shadow? Okay. So let's do this and see if it passes. Time limit exceeded. They're the same. Doesn't matter. Okay. So this actually overshadow that. So we go up, down, left, right. What's wrong here? Possible that it did not add it correctly to visited. If it is inbound, sure, and not in visited, and is one, then I take, right? I don't see anything wrong with it. It's just time limit exceeded. So with this case, right, it goes through this. And it go here. Then again. Horizontal or vertical. What's happening here? The stock market's crazy. Let me check. What did I do wrong? So what's going on here? Hmm. Okay, maybe we have to do this because if we add them down here, right, they'll get into here, right, or whatever. I don't think it's making a difference here. Still limited. Why? So if I do it this way, I'm gonna try to do up, down, left, right. This make sure I only go is it possible that this is still invisited somehow, right? So then I don't do nothing. Right, so this does nothing. Inbound, good, and it's not invisited. So somehow we visit more than we still not added correctly to the visited, right? If I add here, it passed, right? So somehow can we not? Wait, so if we do this and instead of that we do this, that order will be fixed, right? There we go. So I think, right, if we go up, down, left, right like this, the previous one is gonna, okay, I think the order of them matters. So if you have a position, you have up, down, left, right, right, then your queue gonna have, previously you just add them to the end, so you will have up, down, left, right, right? But with this order, you will have, this is actually depth first search instead of breadth first search, right? So that should work. So we don't have to do this, right? So basically, whatever position it is, we visit the up first, and then we keep doing that way, right? But if we add them like this, right, that means you're gonna do up, down, left, right, and it doesn't get cached correctly. That's why we have to do this, right? So we see the differences is here, right? We time out, right? But if we let them expand in a depth first search, right? So depth, basically like feel like video games, right? So if we do this, we actually maintain the order, and it should be visited first. So visit them correctly. The order matters in the way we check visited, right? So yeah, so let's see if this pass. Okay. There we go. Go to the next one. Okay, so they give us all the arrays thing, right? This. Go to the chat. Okay, so what did they say here? Grafting oranges. So this instant is all about array, huh? 0, empty, and every minute any fresh orange that is foraged until rotten become rotten. Every empty and fresh. Fresh. So you have to start with 2, right? And see if you can expand similar to, I guess, similar to the number I learned from, right? Expand. And then the moment you expand, right, you get more orange to rot, right? Right. So you expand this, become this, right? And then after that, the cause these two. So these give you uh these two. These two give you these two, and then yeah, these two give you this, and this give you these, right? Mm. So we keep doing that, and as we go through all the note, right? We check, we keep the position of um, the fresh one, and check if there's still after all this process, um, if it can be, if it is actually marked as visited, right? Marked as rotten, right? Then yeah, okay, let's do that. So if all the rotten is visited, then it's returned. Oh, we have to also expand the minutes, right? So every minute, so each of the state here can keep track of what is their the time, the time that they are rotten, right? So yeah, so we can do that. um so we probably have um forest, rotten, orange, ROM, the rotten orange minutes. Okay, and then we have the same thing we did last time on the previous one. Right. This general structure is right? If the grid y-x is what? Fresh orange. Oh no, 2. Oh, number, right? Then we have a function like we did last time. Plot fill. Um, uh, at y-x, right? So we also have to keep track of fresh orange, right? Fresh orange's position, the set, right? Aleph go 1, then we add it to the fresh. Um, like that. Okay, so now we write our plot fill, and got a y-x, got a q, got a this, y the q, right? So y-x equal q dot pop, and oh, they started at -0, right? We start here, whatever this is, you become oh, so let's just do it through the one path, right? So basically, um, start at this, expand to this, and from this we expand, from these two we expand to these, and okay. So yeah, let's just okay, just start with, if we see anything and y-x is not in rotten, then we start with 0, right? This will be minutes. Minutes, right? Let's call this m. So gotta go for y in what? So let's also keep track of the max minutes, right? So call this minutes. So negative 1, 0, negative 1. Right. If minutes so basically minutes, so max of minutes and m, right? They mention minimum, but it's actually whatever we expand to. We probably have whatever that actually max, right? So now we have to go to up down left right again. Down. Left. Right. So if we have to write the function inbound again. Right. Okay, so if inbound y and this is not in ROM and read up y x y is equal to batch is 1 q will be m plus 1, right? Here we go. So then after we did this, return -1 if lunch of fresh oranges not equal to from other y minutes, right? Maybe like that. We're right here. Let me do global. Python access integer outside of function. Let's do that. Minutes right here. Python accessing, modifying outer integer. Non-local. Okay. Non-local. Keep forgetting. What? Oh, forgot to add. What? So red, oranges. Two two 0 1 2, yeah, 4 here. Why? 0 1. Oh. So let's not do this, right? You have to loop to this one anyway. Right? So you're gonna have to so for orange and if fy okay. Fresh orange count. Fresh orange count. Okay. So basically if this is in ROM minute map minute then if else minute that with 0 and 1 0 2. What happened here? Wait, hold on. Train RC fresh orange and FOC and print ROM. Let's see. Since there's already no fresh orange at minute 0, the answer is 0. Okay, hold on. Wait a minute. Negative 1. There's also the case where there is no fresh orange as well. Okay. So let's do, okay. So this should work. Yeah. Wrong answer. What? This. This. 5. 2. Wait, why? What's wrong here? Do you have two is rotten, so 2, 1, 1, 1, 1, 1, 0, 1, 2. Okay, so minute 0 bad. This is bad. This is bad. Right, this is bad. This is bad. Right. So 2, 2. 1, 1. Two, two, two. Oh. -1, this is -1. Right. The -2. Does it also go? Hmm. So maybe we need to get all the. We have to get all the position of the um one main. So maybe we have to get all the position, because in this case, right, they can go at a different. So in this case, you want breadth first search is what happened, right? So this is breadth, right? So this is this. Right. So let's get all the position of the position to try, right? So let's do we have fresh orange and we have rotten orange. So let's do this. And this is rotten, right? So comment this out. Okay. So now we're gonna have to start with the rotten, right? So we're gonna be on the flat fill for rotten orange and so basically we want to have this is time 0, this is time 1 here, time 1 here as well. and it's time 2 here. So yeah, instead of 5 here, right? um 1 here, 1 here, this one also, 1 here, 1 here, and from these one we got 2 here, 2 here, 2 here, right? So we meet in the middle here, right? And then this guy also 1 2 here, right? Right, so okay. So for rotten oranges, you want to flat fill y-x. It's actually uh if we expand, okay. So why can we not do this? Can be a list or something. Will be added like that. A set equality, Python set equality and complexity. When? Right. So with that first search, we should be fine. Right. So this should be a list. Right. So let's convert that to this. Okay. So you want to do the breakfast search, which is this. And okay, so when we do that for breakfast search, it should be fine. Let's see. 2.0 here. And ROM. Yep. So this is because this has two. This have only one router, right? All of these case. Case 4 is the one. Yeah, this should give you two now. Right. So now you can also do this. There we go. Submit again. Wrong answer. Oh my god. How many cases are there? Okay, so we have 0, 1, 0, 1, 2, 2. Wait, what? Oh, 0, 1 and 0, 1, 2, 3. 2, 2, 1, 1, 2, 0, 0. So these two will make -1, will make this 1. Make this 1. And this cannot do anything. Okay. So 1, 1. What? Do that. So you miscount for some reason, right? So 2, 2, 1, 1, 0, 0, 2, 0. So -0. This go first. It make this bad. Right, and this go first. Let's make this one bad. And because this cannot cross, fine. And this is -1, -1. Oh, did we forgot to add? We did add them. Why? Let's print out the stuff, right? Why it's minutes. What's wrong with this case? So minus 0, yeah, do this. 0, 0, 1, okay, 0, 1, good. Minus 0, 3, 0. Where 3, 0 come from? Yeah, okay. Minus 1, 1, 0, yeah. 1, 1. And okay, hold on. So minus 1, you got 1, 0 and 1, 1, right? So 1, 0 gonna attempt to do, we got these two. Wait, hold on. Minus 0 gonna do this. Okay, minus 1 gonna do this. Minus 1 gonna be this, right? At minus 1 it's gonna say okay, do we also add them to visit it, right? Yeah, let's try that. So that we don't up double counting. Yep. So watch out for double counting and multiple rotten in different starting position, right? The example gave only one rotten, so we have to do red cursor to start all the same time. Each tick. Alright, let's see if this passed already. Okay, submit. There we go. That's fine. Alright. And go next one. Generate parentheses. Given n pair of parentheses by function to generate all combination of well-formed parentheses. Wow. Sounds tough. So we, if n equal 1, we got this. N equal 2, what can we get? You can get these, or let's just do a test case. So we have well-formed parentheses. Okay, so n equal 2 we got, and oh, here. Do this, and that, right? Hmm. Okay, so how do we approach this? Uh, let's check. Okay, so n is a pair. So we want to so they want okay, one pair is this, and that's the base case. Two pair can either be double this, or okay, so basically base case is this, right? Of course n gonna be greater than 1, equal to 1. So n equal 2, that means you can either do this, or right, so that means you can either do base case. Basically, let's say base case is this, or a, right? So you can either do a or that, right? And so n equal 3 gonna be going to do a, right? Or a, right? So okay, so that means we have a, okay, so that means we have either what this case, or what the hell is this? 1 2 3 close 3 and 2, close this, right? So send code 1, I have these. Okay, I need code 2. Then I can either do double A or I put 2 parentheses outside of this, right? So I guess 3 gonna be these or these, right? 3 gonna go right. So basically this I can go this, right? Okay, so I stack basically, so I generate from the base case, right? Or um or I do 1, 2, 3, right? Can I do so I do double this or 1, 2, 3, 1, 2, 2, okay. I do the same. I stack one to the left of it, or I just put whatever they have here. 1, right? So 1, 2, 3. So this is, wait, why do I only have 4? 1, 2, 3, 4, 5. Right? How do you get the 5th one? Wait, which one is the 5th one? So I have this is A here, good. C, D, E, E. So I got B. Right. Did I got C? I got C. And I got E. I don't know what happened to D. So D is something on the left of it. Oh, so you can put it on the left. It'd be different, right? One. Right. So D is here. Right. So at any point, so later on, you either go greater than 1. So you go A. You put it to the left, right? Or you put it to the right. Right? And then we have to have visited, right? Right? So you do this. Or you do this. Or you do A and to the left, right? You have 3 cases where you expand. You expand from the left, right? Expand right. Yeah. Does it have to be in order? Okay. So you do that. Okay, so parent PS is gonna be this. Return this up. Right. Okay. Call this function span db1 and at starting this, right? Right. So 1, 2, 3, right? We only go to level. Right, so we start at 1, start at 0, right? So parenthesis, this is D def, if def is less than just 0, 1, 2, so n is 3. Def equal n, we return, right? Otherwise we can expand, right? B plus this 1 and plus 1, and we can expand B plus 1, and we will also finally we expand plus B plus this plus 1, right? Like that. Of course, we gotta do is ps dot add p, right? If or p in ps, then return, right? Run like that. Whoa. Oh, my bad. E plus 1, guys. Oh, this is the result here. Reveal this, right? Say if he already in the visitor, then return. Otherwise, right? Oh my god. And -1, right? Let's do 1. We have duplicate here, right? Does it has to be in order to, bro? So the first thing we need to fix is we somehow have duplicate. So if it's already in visited, and we return. Why? Why is it not in visited? So we do 2, right? We will have this or this, right? Oh wait, hold on. Or this again. Right, we keep following this. Oh. That should do it. There we go. Submit. Boo-hoo. But is it the same length? Output equal. Expected equal. of output. No, we're missing some cases. So output set equals set of output. Expected set equals set of OS. Um, lambda. We're missing one case. It seems like. Okay. Yes, differences with. Alright, we're missing this case. Okay. Do depth first search, right? So we start with this. We go. We keep putting them. Oh, does it matter though? Let's do this. Okay, so it's 2, then we do this. And 3. Keep stacking. And finally 4. Right. Then we do this. 4. Whatever this is, we edit, right? So our analysis said that we're missing this case. Right. So let's debug our tree here. So okay. Right. And then this one go to from left of this. Right. Why does it not capture this case? So let's say do that. No. Do we have this in there? We don't ever have that even. So we're missing something. Right. Okay. Keep expanding. to okay, and then we did this. So now so now we go this, right? And then look at look how unwieldy this is. How do we able to generate that? Or do we even know if what we said here is correct? Right? How would we miss it this case? So this is likely the case where this is when in a 2 we have the first right. So we got it look like a double 2 here, right? So we got this or this or this again, right? So the case in the middle here basically right now become this. Hold on, let me check. Or feel like we're missing some case here, right? Um, so maybe we can take a break and come back to this because I'm tired. I need to cook. Um, yeah, so let's stop for now. If we can finish this question later, which would be great. But bye for now.